皆さん、おはようございます。望月先生が今日来ることはできませんから、また、僕は一人で授業しますけど、そして、はじめはやっぱりGitHub の Intro Speech Understanding をいつものように開いてください。それで今日は第13講義ですから、第13講義を開いてみてください。あの、あれここには、lecture notebook がありませんね。So, good morning, everyone. Today is lecture 13, and I've just discovered that lecture 13 actually a does not have a lecture notebook in it. So I think we might have to go back to the 2024 spring lecture 13. That one also doesn't. That's odd. What happened to the lecture notebook? Um, hmm. Well, that's very unusual. That's not what we're looking for. Okay, I don't know why, but for some reason my lecture doesn't have lecture 13. The version that I have installed on my own computer does not have lecture 13 notebook. So I'm going to use GitHub Desktop to download it again. Um, okay, let's see. The the uh the main version has it, but let's see if the I'm going to clone a new version actually. Let me create a new window, and how should I do this? And let me just clone this entire notebook. So I'll use the command git clone and then the URL, and that should clone the entire notebook. And then I can run Jupyter Notebook on this version. Here we are. So please go ahead and somehow open Lecture 13 notebook. It for some reason it was absent in my version of in my downloaded copy of the file, but here it is in the version that's available on the instructor page. So please download it from whatever page you can access. 皆さん、ちょうだい、この第13回の、ノートブックを、開いてください。これは、あ僕のダウンロードされたものでなかったけど、もう一度ダウンロードできましたから、そんな問題があれば、 Moichido, sono tokoro kara download shite kudasai. Um, so what we want to talk about today is how to use speech to access your web browser. Now we've done automatic speech recognition and automatic speech synthesis, and we have speech working for synthesis and recognition. And now I want to connect that to the web browser. And I want to talk about two ways of doing that. First of all, by just directly opening a web page. And second, by accessing a web page and parsing it using an HTML parser, and using the HTML parser to extract content that we can then play back using speech. So first of all, in order to open a web page using Python, there are really three packages for using web pages in Python. The first one is called web browser, and web browser is a simple package that just calls whatever your operating system's default web browser is and opens a web browser. The second package is called requests, which is a package that goes to the back end, and in the back end, it accesses a web page and downloads the content of that web page into Python. And then finally, there's a package called Beautiful Soup, which will take the string, the text of the web page itself, and just parse the text of the web page. So you can either use web browser to interact with the web browser program, or you can use requests to interact with the web server program on the internet, and then use Beautiful Soup in order to interact with the text of the web page itself separately. Maybe the simplest of these to use is the web browser. So if I want to use web browser, I simply import the web browser package and then type web browser open, and then the name of the web browser that I want to open. So here I typed web browser open wsj.com, and immediately it opens the Wall Street Journal web page. All right. Now we can use the, I'm not going to be able to do this in Apple because Apple won't allow me to listen to the microphone. But if your microphone allows you to listen to it, then you can print Python as listening, and then you can use the microphone as a source and adjust for ambient noise, and then listen to the microphone, and then try to do automatic speech recognition on the microphone. And for example, you can say wsj.com, and then it will open the web wsj.com. So that will work as if you're working on Windows and if you can actually use the microphone inside of a Jupyter notebook. Unfortunately, I'm not able to do that because I'm working on an Apple computer. So similarly, if you want to do a Google search, you can do a Google search by just typing http://google.com/search q equals. And then after that, you can type the content that you want to search for. And I'll show you just using the web browser, I'll show you how this works. If we type http://google.com/ and then what is the next command? Search q equals in the query. So search q equals, and let's say kittens. Let's say we want to see kittens. So we do search q equals kittens, and Google comes up with kittens. It asks if I allow it to access my location, I'll allow it. And here we have a whole bunch of cute kittens that Google has returned to me. Or we could search for q equals I don't know, starships, and we'll see starships. So here's actually it brought back the song by Nicki Minaj, Starships. All right, so you can use Google to search for whatever you like by just placing it after the Q. If you have a complete phrase like cute cat videos, you can put it in quotation marks and it will search for cute cat videos. All right. That can also be done using the automatic speech recognition if you're on a Windows computer. If you're on a Windows computer, you can print Python as listening and then use the microphone as the source. You can adjust for ambient noise and then listen to the microphone. And once you've listened to the microphone, you can recognize the content that you listened to and then do a web search for that content. So you can search for cat videos or whatever you like. All right, so this is the Python package web browser that interacts directly with your computer's web browser, whatever is the default web browser on your computer. But suppose you want to bypass the web browser and go directly to the web and access the web directly. The way that we do that is we use the requests package to access the web, and then we use the Beautiful Soup package to access the text of the web page. And in order to use Beautiful Soup, you need to know something about how HTML works. Once you download a page from the web is written in a formatting language called HTML, Hypertext Markup Language. So hypertext markup language, you can open it using a plain text file. So if I go back to my file browser, and if I look at the directories where I am now, I think I'm in the directory called Intro Speech Understanding. It's not here. Let's see. Oh, here it is. Intro Speech Understanding 2024 Fall, Lecture 13. You can see that in this directory, I've got grade.py, homework13.py, testpage.html. And so I can use any text editor and open it. Let's see. Can I open it using Emacs, for example? Emacs is a text. Oh, let me open it using Emacs. Emacs is a text editor with a whole set of complicated commands. And you can see that this is just a test page. If I open it using a text editor, I can browse it as a text editor. Here's the title style. It's just plain text. But if I click on it directly, it will open it in a web browser formatted. This is what it looks like formatted. And this is the programming language that specifies that format, right? So here is exactly that format. HTML is the command that tells the web browser to open a new HTML document. Head is the command that tells the web browser to open a new header section. And then this section tells it to close the header section. This tag tells it to open up the body of the web page, and this tag tells it to close the body of the web page. This tag tells it that it should create a header at the top level, and this tag tells it to close that header at the top level. And you see the result is this text is increased in size and made more bold. This tag tells it to start a paragraph, and this tag tells it to end a paragraph. This tag tells it to start a hypertext reference where the text should be blue and the link should be to the page wikipedia.org. And then the text that is that hypertext reference is the word Wikipedia. So if we go to the to the page, you can see that the word Wikipedia here is in blue, and it's a link to the page wikipedia.org. So in this way, you can program, basically a web page is actually a programming language. The programming language is called hypertext markup language. It's a markup language, which is a kind of programming language that's just for formatting a text document. The general structure is that HTML comes in the form of tags, and there are two types of tags. There are these opening tags. Those are the things that are enclosed by angle brackets, enclosed by a less than sign and then a greater than sign. And then there are the closing tags. The closing tags are the same as the opening commands tags, but they have this extra slash character. This extra slash character closes the envelope. It closes the envelope. Every envelope has content, and some also have attributes. So here the word NPR is the content because it comes after the start and before the ending of that envelope. The attributes are these things that are inside the opening tag. So these are attributes. These things are called attributes. And this thing, NPR, is called the content. So the content are the things that are inside the envelope, and the attributes are the features that are marked in the starting tag of the envelope. They are marked when the envelope is first open. This is written here. The content of the envelope is the text between the opening tag and the closing tag. The attributes are defined inside the opening tag. So for example, in this tag, class equals blue text, href equals npr.org, this tag A has two attributes. class equals blue text, and href equals https://npr.org. These envelopes can be nested. So for example, inside the HTML document, we have a header. And inside the header, we have a title. So if we go back and we look at, we have a header, HTML is opened, and it's not closed until here. So inside the HTML document, we have a header which is opened here and closed here. Inside the header, we have a title which is open here and closed here. And we have a style command which is open here and closed here. Then we have a body which is open here and closed here. We have a text heading which is open here and closed here. We have a paragraph which is open here and closed here. We have a boldface envelope which is open here and closed here. And we have an href envelope which is open here and closed here. Right, so you can see that the envelopes are body. Inside body, there's H1, P, 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 and P. Inside the first P, there are two B envelopes. Inside the third P, there's one A envelope. Inside the fourth P, there's one A envelope. So those envelopes are nested in this way. There are many different types of tags. So here's the HTML standard lists lots and lots and lots of tags, as many tags as you want. So you can see the title tag, the language tag, translate, dir, style, inner text, outer text, head, title, base, and so on. The tags that we're going to use in this class are just HTML, header, title, style, body, H1, P for paragraph, B for boldface, and A for hypertext link. There's also one more that we'll see quite often, and that is the div tag. So we'll see that. A real web page is just like this one, but much more complicated. So let's go to npr.org, for example. And then let me show you the, we can actually look at the content. The top news is that TikTok might be banned in the United States within a couple of days. After that, we have information about the wildfires in California. If we go down here to, in different web browsers, this is in different places. On Firefox, we go to More Tools, and then we look at Page Source. So if you find something that says Page Source in your commands on your web browser, then you can look at the hypertext markup language. You see that this document starts with an HTML tag, and this HTML tag has attributes, class equals Node.js, and language equals English. Inside of the HTML envelope, we have a header tag. So we start out the header tag. Inside the header, we have a script tag, which has attributes type equals text JavaScript, and source equals this source. And then this script envelope closes. This particular tag has no content. Notice that between the opening tag and the closing tag, there is no content. It only has attributes. Here is another script tag. Here's its opening, and here is closing of the same script tag. And we go on, it looks like there's a lot of different script tags. This is a comment, so here's a comment tag, and this comment says that if you're able to read this page source, then NPR wants you to know that NPR is hiring. So this is the kind of thing that you can see if you go in and look at the web browser page. Here are more scripts. And finally, I think somewhere we end the head, maybe here. No, not there. Let me see if I can find out where the close heading is. Ah, there it is. So here's where the header of this web page ends, and here's where the body begins. So you can see that immediately after the header ends, the body begins, and the first item, this body has these attributes, And then what will be the first item in this body? Well, the next line will be something that looks like back here with the first envelope inside the body is a div envelope. All right. So basically what I wanted to show you is that a real web page looks just like this toy web page. This test web page that I've shown you up here has an HTML document tag, and then a header tag and a closing header tag, and then a body tag and several paragraphs followed by a closing body tag. The real NPR web page looks exactly the same. It has a heading tag followed by the close heading, followed by a div tag and several span tags, a list item tag, and then here's an href tag. So you can see that all of these things that exist in the toy web page also exist in the real web page, and the real web page has a number of other different kinds of tags, UL tags, for example, and LI tags. Those are list index tags. So you can edit a web page using any text browser or using any web programming language, but you can also use Python to extract the content. And the way that you do that is using the easiest way to do that is using the Beautiful Soup package. What the Beautiful Soup package does is it gives you programs for searching through all of that long text file with all of the formatting and finding the particular content that you want inside of that package. So for example, suppose that we want to find all of the paragraph tags in a document, all of the P. We can use that using find all P to return a list of all of the paragraphs inside a document. So if I open testpage.html as F, and then I will read in the beautiful soup from F using the HTML parser, then I can take that example beautiful soup object, and I can find all of the paragraph tags and return them. And inside that document, we find that we have one paragraph saying web pages are written using the hypertext markup language. The third paragraph is just the hyperlink for Wikipedia. So there are 4 different paragraphs inside this document, right? So all I've done is I've created a list of all of the paragraphs, and then I print out the number of paragraphs in the document, and then I show the first one is, and I print the first paragraph. The third one is, and I print the third paragraph, right? And the children of the third paragraph are, and I print the contents of the third paragraph. And you can see that the contents of the third paragraph are one new line, and second, an A hyperlink, and third, another new line. So the contents are these 3 things in a list. If you know that in advance that the third paragraph contains a hyperlink, you can find it by taking the paragraph tag and saying inside that paragraph tag, find me the hyperlink. And when we do that, we find that the hyperlink has as its content Wikipedia and as its attribute wikipedia.org. So the href attribute of that hyperlink hyperlink is wikipedia.org, and the content is atag.text. Right? So there's Beautiful Soup has more to learn than we can possibly learn in just today, but if we go to the Beautiful Soup webpage, it has a complete information, including documentation translated into both Chinese and Japanese and Korean and Brazilian Portuguese, Spanish, and Russian. So you can look at the documentation in any of those 6 languages or in English. All right. So now let's use that to explore a real-world web page. Let's get the NPR web page and let's find all of the paragraph tags and find out how many paragraphs there are. So we'll list the first one and we'll list p tags 0, and the third one and we'll list p tags 2. And we're going to use the requests package to get the web page. Requests is, I told you there are 3 packages to deal with the internet in Python. First is web browser that interacts with your operating system's web browser. Second is requests, and that goes directly to a server on another computer and requests from that server information about the web pages that it serves. And using requests, we can get the entire text content of the top page at npr.org. And so I can take that text content as webpage.txt, and I can parse it using Beautiful Soup in order to get a Beautiful Soup object that I can search for the content of that web page. And then inside that Beautiful Soup package, inside that Beautiful Soup, I can find all of the P tags, all of the paragraphs. And I'll find out how many paragraphs there are in the document. And I'll list the first paragraph in the document as P tags 0. And I'll list the third paragraph in the document as P tags 2. So if I run this, it will actually go to the web and download npr.org. And we see that the first paragraph says the Supreme Court is considering whether to block a law that effectively bans TikTok in the US starting January 19th. So the top news story, the top paragraph on npr.org is about the possible ban of TikTok in the United States starting on January 19th. The third paragraph on npr.org says that a car drives Sunday past homes and vehicles destroyed by the Palisades fire at the Pacific Palisades Bowl in Los Angeles. So the third top paragraph on npr.org is talking about the Palisades fire, the Pacific Palisades fire in Los Angeles, which is still out of control. The fire is still spreading in Los Angeles right now. In order to learn more about a particular web page, we need to know something about how the designers of that company have designed their web page. So in NPR, for example, the news stories are stored in div packages, in div envelopes. Every news story is a separate div. So we can download, there'll be stories of type div with the attribute story text. So if we find all of the div tags story sections, we find that there are 46 story sections. And these story text sections, if we go to the NPR webpage, let's see. Let me just bring up npr.org again. We can see that each of these story sections includes a title, and some of them include a summary as well. And then often they will include a photograph. If we want to get all of that information all together, we can download the entire div tag if it's a div tag that has the attribute of story text. So these are div tags that include, here we see this is a div and its class is story text. So it has the story text attribute. And inside that story text, we have another div inside of it. And inside of that, we have a header. And the header includes the word technology inside of a link. We also have an href, and that includes homepage curation click. This is about advertising, apparently. We have an href, which is about data metrics. This is about advertising also, I think. We have a paragraph, finally, which has the class of teaser. It says, even if the controversial US ban on TikTok does take effect on January 19th. Oh, and we also have an H3, which has a class of title. A TikTok ban could hit the US. So if we go back to the web page, we see the this one, H3 class equals title. That's this title. A TikTok ban could hit the US in days, what to know and how to prepare. And if we go back here, we see that this paragraph that has the class of teaser, the teaser is this text underneath. This text that says, even if the controversial US ban on TikTok does take effect, et cetera, et cetera. So there's two pieces of text inside of each story on NPR. There's a header, a title, and then possibly a teaser. NPR calls this one the title, and it calls this one the teaser. The title is the thing that's in large font, and the teaser is the thing that's in smaller font. Notice that not every story has a teaser. Every story has a title. Here's a title, here's a title. But these stories don't seem to have teasers. They seem to only have titles. Many of the stories on the webpage seem to only have titles, no teasers. All right. So the third story, for example, here's the class story text. Here's the advertising. And then Where is the H2? Oh, H2 class, California wildfires. Oh, here's the title. H3, class equals title. Fires in Los Angeles delay Oscar nominations once more. All right, so we have the title is down in H3 now instead of H2, but the title for this story is Fires in Los Angeles delay Oscar nominations, and you can see there's no teaser. So each of them has a title, which is called H3 class equals title, and some of them also have a teaser, which is called paragraph class equals teaser. So we can extract those story text. Given this beautiful soup object from the web page, we can get the stories by just creating a list. And for every div tag that has a story text attribute, we can extract from that div tag the H3 tag that has the title attribute. And we can extract the P tag, which has the teaser attribute. If the teaser tag is not equal to none, then we'll append the tuple of text and of title tag and teaser tag. So we'll append those two things together as a story. If it only has a title, then we'll only append the title tag to our stories. Let me define this as a function, and then let me apply this function to the NPR. We find that there are 46 stories, and story number 0 has this title and this teaser. Story number 1 has this title and no teaser. Story number 2 has this title and no teaser, and so on. And we have a long list of titles and teasers. What I've done here is I've taken this visual content, which has a lot of photographs and so on, and I've turned it into a pure text content that I can read using speech. And so I've taken something that is useless to a blind person, and I've turned it into something that might be useful to a blind person, right? The idea is to take the web browser and turn it into something that you can listen to without having to look at. You only want to be able to just listen and not have to pay attention with your eyes. So we can use GTTS in order to synthesize the stories. I'll create read story list, where stories is a list of the stories, and it will just list off all of those stories. And then I'll read the nth story. So let's see, let me import GTTS, and let me read the story list. So I'm going to synthesize an audio that lists off all of the stories in today's NPR webpage. And it seems like it's taking a long time to synthesize. Right, so the read story list, it takes a list of stories and a file name into which to write the audio. The text will be, here is a list of today's top stories, and then I'm going to concatenate to that text story number D, where D is the N, the number of the story, and %S is the text of that story. And then once I have all of these concatenated together into the text, then I'll use GTTS in order to synthesize that audio, and I'll save it in the given file name. And the result sounds like this.
Here is a list of today's top stories. Story number 0. A TikTok ban could hit the US in days. What to know and how to prepare. Story number 1. See some of the most terrifying and dramatic pictures of California wildfire devastation. Story number 2. Fires in Los Angeles delay Oscar nominations once more. Story number 3. Family remembers Victor Shaw, killed in the Eaton fire, for his bond with his sister. Story number 4. As the U.S. ages, dementia is on the rise. Here are ways to reduce your risk. Story number 5. Special counsel in Hunter Biden case denounces president for criticism of the probe. Story number 6. The first full moon of 2025 is here. Story number 7. Judge Cannon paves the way for potential release of Part 1 of Special Counsel's report. Story number 8. Biden puts AI and climate at the top of the list for Trump administration.
Okay, and so on. It looks like we're only 1 minute through a 6-minute narration of all of the 47 stories, all of the 46 stories. So let's use read nth story. For read nth story, this function is going to take a list of stories and the number of the story we want to read, and the file name in which to store the resulting audio. And I'm going to take the nth story, its title, and the nth story's teaser, if the teaser exists, and I'm going to synthesize it in English, and then just save it into a particular file name. So let me read the nth story, and I'm going to use the input in order to ask the user, which story should I read? Which one should we read? Um, how about yeah, does anybody have any preference for which story we should read? Go ahead and put it in the chat if you'd like to read any particular story. I think we have 46 stories. Anybody have a preference? Somebody type a number in the chat. Eh, Thank you. Let's try 5. All right, now I'll read story number 5.
Special counsel in Hunter Biden case denounces president for criticism of the probe.
Okay, so it read out the title, and it would read the teaser if the teaser was there, but since there is no teaser for this story, it only read the title. All right, so in this way, we can take a web page and use Beautiful Soup to extract just the pieces of text that we know to be important, and then to play them back to us. There's a lot more that I could say about Beautiful Soup and about parsing web pages, but I think that's enough information for us to go ahead and do the homework. So let me go ahead and tell you about the homework. The homework has 2 sections, which are basically extract the stories and read the nth story. So they're very similar to the functions that we've just done. The first function, extract stories from NPR text, takes an input text string and extracts a list of stories from that text string. So we want to use Beautiful Soup to extract the beautiful soup from the stories, and then from those stories, we want to extract a list of the stories where each story should be a tuple of title and teaser. All right, so let me try to open up the homework. That's not the right one. Um, I may have, I may need to start the Jupyter Notebook again. Let's see. Okay, so the notebook includes two functions that we have to write: extract stories from NPR text and read nth story. So the extract stories from NPR text should extract a list of stories from the text of the npr.com webpage. So this is going to be very similar, I think, to the things we've done in the notebook. Let me go up here to where we've extracted the stories. We want to find a soup object. How do we get a soup object? I think we use that using Beautiful Soup, something like this. So we want to create a soup object from the text of the web page like this. So I want to do something like npr soup equals bs4 of the input text, not the web page text, but the input text. And in order to do that, I want to make sure that bs4 is imported. All right, once I've created the soup object, then I need to extract the stories from the soup object. So that will be something like this getStories function. I want to create a list of stories, and then for every div tag that has a story text attribute, I want to find the H3 title and the P teaser and then concatenate them together. So let me actually just copy all of this content and try adding it to this function. We want stories to be a list, and then for every div tag in NPR soup find all div story text, we want to find the title and find the teaser, and then append that story to the list of stories, and then finally return the list of stories. All right. I think that does everything I need. Stories should be a list of tuples of strings. Each story should be a tuple of title, comma, teaser, where the title and teaser are both strings. So that seems to be what I've done. And then second, I want to read the nth story. Given a list of stories, given a number n and a file name, I want to save the story. And that's very similar to, I think, what I've already done under read nth stories. Where did read nth story go? Oh, here we go. Read nth story. Oh, I just used GTTS to do that. Let me see if I can just use GTTS. So I just use gtts.gtts, text equals stories n0 plus stories n1, language equals English, and I want to save it in the file name. All right, so let me try saving this. And then let me try going back to the web page and see if the web page thinks that I've done that correctly. Homework third, where does it, where is it asking for homework 12? Oh, there's an error in the grading function. Let me edit the grading function. Grade.py is asking for homework 12 when it should be asking for homework 13. So we can go in here and actually edit the grading function so it asks for homework 13 instead of homework 12. Where does it ask for homework 12? I don't see anything asking for homework 12. Read nth story. I may have an error in the version that I'm looking at. Let me try opening lecture 13 notebook in this web in this directory and see if that runs correctly. Let's see if I run this here. Well, that's interesting. I don't know why it thinks that grade.py is asking for homework 12. Let me try finding homework 12. No, it's not in this, not here. That's strange. I don't know why it thinks it's looking for homework 12. Oh, maybe. No, there's nothing here that should be asking for homework 12. Hmm. Oh, no, it's here it's here in the notebook. I'm sorry. It was right there. It was asking for homework 12 and it should be asking for homework 13. Now this should work. So I've just corrected the web page to ask for homework 13 instead of homework 12, and I had it load the web page content and read.
A TikTok ban could hit the US in days. What to know? and how to prepare even if the controversial.
Okay, so it's reading story 0. All right. If that's all good, then let's try seeing if grade.py actually works. Oh, and it looks like grade.py works. All right, very good. So now that that's happened, we should be able to go to GitHub desktop and correct homework 13 and push it to the origin. Actually, I'm not sure if I'm going to have a version problem here as well, but let's find out. And then we should be able to go to github.com and click on Intro Speech Understanding 2024 Fall, Lecture 13, Homework 13.py, and note we did have a version mismatch. Let me see if J. Hasegawa student has it. No, there's a problem here as well. I think that the problem is that I'm writing it into the wrong location in my computer. So I think that if I open up homework 13.py and if I save it somewhere else, let me copy all of this and let me open in my text editor, um, documents, GitHub. Oh, that won't work either. That's interesting. Maybe I should just try text edit. Here we go. Now we're in 2024 fall. Let me go to lecture 13 and I'll open homework 13.py and we can see that this is the same version that's on the GitHub page. And so let me replace it with the version that I've edited. There, now we have the version that I've edited. Now let me save it. Now it should be saved to the correct directory. So if I go to GitHub desktop, I should be able to try homework 13. Oh, and we can see that the changes that I want have been made in this version. Commit it to main, push to origin. And now when I go to GitHub, I see that it has actually changed. So now that I've actually got my GitHub repository to show the changes that I made, now I can copy it and go to speech understanding, go to Canvas, and open homework 13 and enter the URL of the web page that I just uploaded. So please go ahead and make those changes to your homework 13 and upload it to Canvas so that I can take a look and make sure that you've done the homework. For right now, that's all we have for today, except for attendance. So let me go ahead and open the campus plan menu in order to take attendance. All right, everybody, please go ahead and register your attendance using this code. Thank you. 皆さん、このアテンダンスをこのコードでやってください。お願いします。 Thank you. See you all next week.